Hello Internet. This 4080 Super from MSI rejection spile came in for repair with an arrow that you usually see on a Gigabyte card. Very interesting design, by the way. Reminds me of a Founders Edition, but much better. Anything is better than Founders Edition if you ask me.
You suck.
In any case, let's take this thing apart and see what's inside. Yep, it's a Founders Edition knockoff. So before we deep dive into the crack repair process, it's worth checking the resistances in the key areas, such as 5V, this here is 1.8 without the coil, believe it or not, 1.2, memory, and PEX. I wonder why they ditched the coil for the 1.8 volt rail in this case. Maybe because this rail doesn't require a lot of amps anymore? I don't know, and I don't really care. Instead of debunking this, let's go ahead and try to get this crack fixed and see what happens. Crack is done, and I accidentally forgot one more wire here on the top, so I'll go ahead and solder that one real quick. And now we're ready to power on the card and see what it does. As soon as they flip the switch, most of the driver MOSFET starts to glow like Christmas tree. But two of them are the most obvious ones, so I'm going to treat these as a primary suspects. This could happen when the core is dead short, but using this milliohm meter, that's not the case. And with that there, we can continue with the replacement of these two driver MOSFETs. MOSFETs replaced, but after powering things on, it seems the board is now dead short. Thinking one of the two driver MOSFETs I used were causing the problems, I removed them and tried again, but the result was the same. More observation under the thermal camera revealed that these two driver MOSFETs emit hardly noticeable heat signatures, so I will replace them both and try again. The short is now gone, but once card is power on, the exact same thing. Thinking that maybe this wire wasn't soldered in the right place, so I went ahead and I cut the wire in half and tried again. But nothing changed, except one thing. We now have a short again. Not sure why. I remove those two again and the short is gone, so It seems like something is killing these driver MOSFETs, and I think I know what it is. You see, this crack is very long, and I suspect there are several feedback signals that were cut. Unless the driver MOSFET can read the voltage at the end of its circuit, it will think that it does not produce enough power, and it will continue to push more and more until it burns out. I suspect that this is exactly what's happening, considering how far this crack goes. Here you can see that it goes as far as reaching several data lines that may be affected. So I'll go ahead and check the last data line and see if there's a connection, and it looks like there is. But still, given the fact that the crack signs are so close to this area, I decided to dig all the way up to here, and I found many traces that are cracked, as you can hopefully see. So let's fix that and see if that solves our problem. There we have it. 1.2 amps, nothing's getting overheated anymore, so I guess we have a fix.
Nice.
I'll go ahead and finish up with the crack by making it look somewhat acceptable. Then I will put back the two driver MOSFETs and power on to confirm we have a fix. At this stage, I'll go ahead and verify all the phases with an oscilloscope to make sure that all of them look the same, and then test the data lines to make sure that everything is good, which has revealed that we have several problems, as many of the LEDs are not lit for some reasons. At first I thought maybe a few of the traces were actually broken on the back, but no, it was actually those at the front of the board. Few pairs were reading open line, and that means only one thing. It means the contact between the core and the board has been broken, but I think we have enough to test the GPU and see if we can at least get the post. And it looks like it does post, so at this point it makes perfect sense to reball the core and see if we can finally make this GPU work again. Too bad it's 2:30 in the morning, so I'll have to do this tomorrow. Okay, a reball is done, and the data lines are now normal, but the resistances are not normal. To be specific, we have a dead short on 12 volt. After spending enough time with a thermal camera and voltage injection tool, the short disappeared on its own. I've seen this several times in my practically non-existent career, and my understanding is that after heat treatment, some capacitors like to turn themselves into 0 ohm resistors, until enough voltage is applied to turn them back into the capacitors again. I don't know why that happens. If you're an electrical engineer of some sort, please help me understand this rare but not uncommon behavior. In any case, the short has magically disappeared and everything else seems to be okay, so let's put this thing together and run some tests. That's it for this hemorrhoid developing repair. I hope I earned your subscription, and if not, at the very least, please hit the like button and comment below. Goodbye.